Okay, this is about color coding. So what are things given? Resistance 200 ohm. If one replace, okay. Very simple. Red is second. Band of red color is 2. Green is 5. Directly we can say it's 500. It's this is red. Okay, this is red. So you remember this way. BB Roy goes to Bombay via Gateway. I remember this way. So nearly it will be 500. Next one. Red is 2, then green is 5. It's very simple as that. Try for this question. See, for 11th standard, those who haven't started this chapter, don't worry. Anyhow, we are going to start on May. Okay, dear, don't worry about that. Especially we are just, as I said previously, I'm focusing for 12th standard. Those who are appearing next month exam. I want to make them revise quick. Okay. Try for this one. Vishwanath, have you tried? You got the first one, right? It's easy. Vishwanath? You there? Am I audible? Yes, people, am I audible? Okay. Vishwanath, are you there with us? Mr. Vishwa? Mm-hmm. So you got first answer, right? Dhairya? Dhairya, you also can type in chat box. Okay. So there are 3 resistors on this side and 4 on that side. But actually, if I add all, it is just 3. If you observe this, what is value? 2. If I draw it again, it's 2, sorry, 1, 1. This is,
Sir, are we not going to be doing theory part for this?
sorry,
Are we not going to be doing theory part for the 12th grade chapters?
no, this, yeah, we will do that, but especially I'm taking class for this 12th standard host, those who are appearing for next month. They already have studied, so just
Yes, sir.
making them revising. Quick study.
Okay, sir.
For you, we'll be doing again. From May properly, we'll do it again because you haven't started, no?
Yes, sir.
Yeah. Yeah, by the way, I can ask him also. Vishwanath, do you want revision for chapter, theory part of this chapter, or shall we start with directly numerical only? Because this chapter theory is small only, not a big, not much in this. What do you say? Okay, so what are 1 given? R1 is 1, 1. 1, 1, then this is 2. Okay, then this will become 2, this will become 2, this will be 2. That means 3 connection, 3 batteries. Simple. We can find out this one now. If I make an easy circuit, Okay, you want theory part also? Yeah, sure. We can go with theory also. Okay, then let me just finish this question and we can go with theory also. This is how many voltage? Two, no, four voltage. So they all are in parallel. So V equals to E equivalent I by R. Simple. So how to find I? E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. Equals to E1 2 by 2 plus 4 by 2 plus 4 by 2 divided by 3 by 2. So 2 will get cancelled. 10 by 3, which is 3.3 voltage. Yes. Okay, you want me to go with the theory also? Then let's do theory now. Just let me open my note. Okay, I'll go with some important points which I have written in my notebook. So that will be helpful for you. Okay, I'll read out. If it is important for you, you can write. Okay, just few notes, not much. Then let me write here. It's better. So first, as I started, like this is the formula which we gave. That is what instantaneous current. It is instantaneous current. So if I want to find average current, same. This will be your average current. So you know ampere, how to find ampere? 1 ampere equals to 1 coulomb by 1 second. If I want to define ampere, what is that? 1 coulomb of charge passes through cross-sectional area in 1 second. There is 1 ampere. And it is tensor quantity, not scalar, not vector, because it is scalar, but it does not follow vector law. It requires direction, but does not follow vectors law. Like vector addition, it does not follow vector addition. It does not follow vector addition. So it is tensor quantity. So now application we wrote that formula we wrote I equals to integration. I'm sorry. This is differentiation. If I want to find Q, I will integrate I t with limits t1, t2. This was instantaneous current. This is application. Yeah. Can you all hear me, right? Can you all hear me? Okay. Okay, fine. So this is for like with respect to time. In short, what we are saying, current varies with time. So then charge will be varies from time interval is t1 to t2. Okay, so now next thing, if I want to find for nth particle, so that's what we wrote there. I equals to n q by t for nth particle of charge. If I want to find like having a q charge and passing through cross-sectional area at that time t, so it will be nq by t. Now suppose a charge is moving in circular path. With velocity v, r is radius, and this is your axis of rotation. So if a point charge, this is what a point charge q is revolving around the circle. You can see the circle and radius r with velocity v. So time period for that will be 2 pi r v. R by v is 1 omega. Okay. Now what is drift velocity? Okay, yeah, 11 people. Like, what have you studied this chapter, Anjali and Adyasha? Have you studied this chapter? Have you started?
So we just started.
Okay, just started.
Yeah.
Okay, and Adyasha didn't started. That's what she's saying. Okay.
Yes.
Okay, no problem. It's okay. You try to understand whatever I'm saying. Okay, this meeting is not upgraded. Right? Okay, fine. In 10 minutes, once it gets completed, you just join back. I think so. Only 9 minutes left. Once it is completed, you join back. Okay, now what is drift velocity? It is just simply, if I say in simple terms, it's average velocity of free electrons. It is an average velocity of free electrons, which is inside metal. Okay, so if we apply some electric field, it will start current. It will start conducting current. That is your drift velocity. Simple terms. Again, I'll say what is drift velocity. It is average velocity by free electrons inside some metal. So, and we apply electric field. That means it will result in current conduction, inducing, I mean to say. So as I already wrote formulas and in above, if you have noted this, these are some formulas. Noted. So if I give you till you write just and listen, like if I give you some information about drift velocity, so as you know, it's about 10 to power minus 4 meter per second average. It's not approximate. It's not exact. You can say approximate values. This was approximate values. So greater the electric field, greater will be the drift velocity. So V is directly proportional to E from the formula. See this? From this formula, we can say V is directly proportional to E. So greater the electric field, greater will be the drift velocity. And direction of drift velocity is for electron is opposite to direction of electric field applied. It will always be opposite. Like is a metal, and these are electric field here, so it will be opposite to that. So that's why center it will be E equals to 0. Now current density. What is current density? Current density. What is current density? Simple. Current per unit area. That is current density. Current per unit area. That is current density. And it is a vector quantity again. It is vector quantity. Formula you already wrote. So if I don't want in vector form, I can write this way: J equals to delta I into delta S cos theta. And this theta is the angle between them. Delta S or A, whatever it is. So di equals to j ds cos theta. So I equals to integration of j ds vector form. And dimension of j will be a l minus 2 because ampere per meter square. So if you compare with this one previous topic like flux, what was the flux there? Phi. Magnetic field lines passing per unit area. So we'll field line passing per unit area. That was magnetic flux. Right here, current density. In that, current is passing through it. So we can say current is the flux for current density. Next is relaxation time. So what is relaxation time? Tell me. I'm waiting for your answer. Quick, quick. Anyone? No? Okay. It's a time interval between successive collision. Time interval between two successive collision of electrons with positive ions. So R equals to, if I say 2ml and E square T by A. This is relaxation time.